So let's look at this problem. I know a lot of students keep asking me, is this chapter in the final or not? Yes, they just put this in the final. We have to analyze for the reactions for this hinge at point A, which has the reaction AX and AY, and that's what he wants to find. Find the reaction, provided that the mass of this load is 80 kilogram. Of course, we don't like to put 80 kilogram. We will do it in newtons. So 80 times 9.81. Okay. When you multiply 80 kilogram times 9.81 meter per second square, you will get 785 Newton. 785 newtons. So now, let's look for this. This is an unknown, and this is an unknown, and look at the cable. We have a cable, but remember from the pulley that this tension is equal to this tension because it's the same cable. So let's draw the free body diagram of this beam. This is the beam. We have reaction AY. We have reaction AX. And we have point B. There's a tension, just called tension T. And this is point B. And the distance is 2 meters. And we have another tension, which is the same T, but with an angle. And this is point E. For 3 and 5, and that's point E, and that is 2 meters. And that is point C. You see the loading is going up, going down 785 in Newton. Now what to do with this type of analysis? The best is to take moment at point A. When you take moment at point A, you cancel AX, AY. It's not included, and you could find the tension T. So let's find summation of moment equal to 0, and I'm assuming this is negative. So this tension, just do it in black, this tension produce what? Produce a positive moment, tension times 2. And this tension will have one in the vertical and one horizontal. The one horizontal will not have a moment because it is at the same line of the action of point A. So let's find this tension. It's tension times 4/5, and this will produce a moment positive around A. Times 4. That's the distance between point E and A. 4/5 times 4. Okay? And then what we have? We have this load. Let's see, this load. And this will give you a negative moment, minus 785 times 4, 5.5. The whole thing is equal to 0. Okay. So let's see, 2t, 5, okay, times 5.5. Let's just plug it in. Tension is 830. Newtons. Later on, we will do summation of forces at the X, summation of forces at the Y. So summation of forces at X equal to 0. We should put our assumption. And this will give us, this is This is AX positive, and this one is negative, minus T, and if you want to make it the x-axis, 3/5 equal to 0. Tension we know, we know it's 830. So 830 times 3/5, and that is equal 498. Newton, and that's AX. Let's do AY. This is going to be AY plus tension plus this tension, that's plus 830, plus this tension plus 830 4/5 minus 785 equal to 0. So now let me just check this again. Okay, we'll do this. And this would give you an AY. Let me just do this later. Okay, 830 times 4/5 minus 785 plus 830, and that is AY is minus 709 Newton, which means that AY is 709 Newton, and it is opposite in direction. And this AX, it was plus, so this is the direction. The tension, of course, it's a tension, so this you don't have a direction for this because it's pulling the point P and point E. So this is the final answer for this. I know a lot of people were asking me about this because this was not in test 2, but this should be included in the